All right, today we're going over how to prove a quadrilateral is a parallelogram. So there's 4 different methods to do. We're going to, because this is notes, go over the 4 different methods, and then you can pick one that's your favorite that you always do. So these are based off of just the properties of parallelograms that we already did two classes ago. So all of these properties that we filled out, or this chart that you have, when we're proving, all we're doing is showing that one of these is true. Or sometimes 2 of them, depending on the shape. Some of them meet more. So we can show that diagonals bisect each other. We can show opposite sides are parallel. And we can show opposite sides are equal. These are all or. We get to pick one or the other. Or we can pick one pair of sides that's both parallel and equal. So based on the information I have here, which of those is going to be the easiest to prove? Or which ones?
Opposite sides are parallel.
Yeah, opposite sides are parallel. So parallel just is based off of slope. So I can really easily say, which 2 lines here are parallel?
2, 4. M-N-O-L.
So M-N-O-L and L-M and N-O. So my parallel symbol, remember, is just 2 lines up like that. So L-M is parallel to N-O. Because it's a proof, I'm going to put the slope there. Okay, they both have a slope of 0. And it tells me I have to show both pairs. So MN is parallel to OL. They both have a slope of 5/2. So as we're doing proofs, as we're like adding in different shapes and stuff, I tell people always start by telling me which lines are parallel. Or if nothing's parallel, tell me what's not parallel. And you back up your statement with the actual slope that you've calculated here. All right, if we skip on to method 3, show both pairs of opposite sides are equal using distance. What are my distance numbers down here? What are my distance numbers? These. And so do you remember last class how we talked about slope is direction, distance is how far apart you are? Did we do that in this class?
No.
Yeah. We did that in this class, right? So slope tells me the direction I'm going, so that's how I can figure out parallel or perpendicular. Distance tells me how far apart the points are. And so when we're talking about how far apart they are, we use the equal sign. And so LM is congruent or is equal to which side?
N-O. No.
NO. What's that distance? 6. Nice and easy, right? And then my other 2 sides, MN is equal to which one? OL, they're both square root 29. All right, method 4 is not something I ever choose because it's just take one pair of sides. So like ML is parallel to NO with 0. And ML also equals NO with that distance of 6. So that's an option you can do. We're going to real quickly show you how to do it. If you didn't have the sides figured out and you didn't want to find out all 4 sides, we can just find the midpoints of the diagonals and see if they equal each other. So method 1. Does anyone remember, it's been a while, does anyone remember midpoint formula? And so that's our slope. Midpoint's almost the same as that we add them. So midpoint is x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So if you don't have slope or distance, you just have the points. Midpoint is a fast way to go it because we just plug in our diagonal. So diagonal would be LN. And so I'm going to add my x's. So negative 2 from L to N is positive 2. And then divide it by 2. I'm going to add my y's, which would be my 3 plus negative 2 divided by 2. What's negative 2 plus 2?
0.
0. What's 0 divided by 2? Just 0. All right. 3 minus 2? And so then that we're going to leave in fractions. So 0, 1/2 is my LN midpoint. And then my other diagonal is MO. And so M is 4 minus 4 or plus -4. Taking my x's from my M and my O, and then 3 and -2. Does it come out the same? Yes. Who wants to jump up into the... Okay, so midpoint I'm going to go over again. Were you guys with me on the formula? So that's just the formula we plug them into. So I came up here. I need diagonals I know are going to go straight across. So LN is one diagonal. And so I just came up here. I shouldn't hear any other talkers. And I took my LX, which is -2, and my NX, which is 2, and plugged them into the formula for X1 and X2. And then I took my Y's. So LY and Y, plug them into the formula.
Why is there a timer on it?
Because we're recording. Okay, and then same thing when I went to MO, I took my 4, -4 for M, and then O, and then 3 and -2.
Wait, so that cancels out.
Yeah, so it cancels out to 0, and then 1/2. Okay. It will go on YouTube, yes.
YouTube?
And so then, if I'm writing a proof statement, I would say LN midpoint equals MO midpoint. And that's with 0, 1/2. So the really good news is, these are 4 different methods. All of these are equally accurate. So if midpoint confuses you, you actually don't have to use it. That's an option. If you're happy with this just counting out slope, you can always default to the parallel. I always choose this one because it's my favorite. Slope is easy to count out real quickly. It's easy to calculate. And so that's my preferred proof statement for parallelogram. So what I would recommend is pick one that you always use. Okay, so right now go ahead and star of those 4 options. Which one is your favorite one? Star it on your paper. And once you've done that, flip over to the next page. The slope one is the parallel. Method 2. Okay, so when we're proving something is a rectangle, rectangles have to have 2 layers of proofs. So rectangle, rhombus, if we come back to this chart, and y'all look up here with me, this really helps with knowing just how many proof statements you need. So parallelogram is here. We just need that one statement saying opposite sides are parallel, or we could choose the congruent or bisects. If I get down to rectangle, I'm 2 levels down though, so I'm going to need 2 statements. So I'm going to need to say opposite sides are parallel and the 4 right angles. Or I could choose diagonals or congruent. When I get to rhombus, same thing. I have to prove that it's parallel in the parallelogram box, and I choose one of these. How many statements do you think I need for squares?
4.
So how many levels in is square? 3. So when we get to squares, we're going to have 3 layers of statements because we have to show where they all overlap. And if you want to write this here, just because this will help you when you get to that open notes test in the end. Alright class, if whiteboards seem distracting during notes, we'll have to not allow whiteboards in this class period. Okay, so you should be writing notes in your packet, not notes to your friends. Okay, so when it's a rectangle, we have to have 2 statements. So we have to have parallelogram first. I'm always going to default to my favorite, which is opposite sides parallel. And then we get to choose either method 1 or method 2 on which one do I prefer to write out. So on here, I'm going to draw on desk first. Okay. So I'm gonna start by saying opposite sides are parallel because this has already told me it's a rectangle. So would desk number 3, which is ocean, which line is parallel? If I'm looking at slope here, which line is parallel to GH? On the graph thing or on the slope that they've worked out for us already? Yeah. So GH is parallel to IJ and GH. I'm going to do the line symbol on top of them and then say both of those slopes are 1/2. So next I need to find my second set of parallel lines. So desk 15, if I start with HI, what is my parallel line to HI? JG. So if you're ever mixed up on any of these proofs, start by writing what's parallel. Okay, that's always the starting point. And if nothing's parallel, that's even better because there's only 1 or 2 options where nothing's parallel. Okay, so I started out by writing what was parallel. And now I'm going to go to my rectangle proof. And so next I can show diagonals are congruent or show it has a right angle using slope. What does right angle mean when we're talking about slope?
Not bent.
So it means not bent?
Not bent.
What was that word we learned? Parallel, and what's our other word with slope?
Obtuse.
Also starts with a P.
Parallel. Parallel.
And the other one?
Polygon.
Perpendicular, okay? So perpendicular slope, which means they're opposite reciprocals, and we use this symbol. Are these perpendicular slopes?
Yes.
Yes, because 1/2, flip it over to 2/1, make it negative. So what I do to keep things really steady is when we're dealing with rectangles, I'm going to just say, hey, all of these are perpendicular. So I'm going to write out my statement. GH is perpendicular to HI, which is perpendicular to IJ, which is perpendicular to JG. And then as in my proof over here, I just say, hey, our slopes are 1/2 and -2. Those are the 2 slopes. So you guys, is that enough now to prove that that's a rectangle?
Yes.
Yeah, because I got my favorite parallelogram statement. I got one of the methods of rectangle. So if you have that slope and distance, you can prove it that way. Or I'm still going to show you diagonals are congruent. If you haven't figured out slope and distance, sometimes it's faster to figure out diagonals because there's only 2 of them. So if I do diagonals, is congruent talking about distance or slope?
Slope. I mean distance.
Yeah. So congruent means distance. And so my diagonals are JH. Is that an easy distance to figure out?
Yes.
Can we just count it?
You can do rise over run.
Well, distance isn't rise over run. Distance is just how far apart are they. So I can just, this distance happens to be just straight along that line, so I can just count 1, 2, 3, 4, 5. Okay. Now IG, which is my other one, I can't just count straight because it's a diagonal. So that one I can count my rise and run, do Pythagorean theorem. I can label the points and plug them into distance formula. How many of you like counting in Pythagorean theorem better? How many of you like distance formula better? Okay, so it's completely your option. I prefer counting. When it's already graphed for me, it's faster to count 1, 2, 3, 4. So I have 4 and then 1, 2, 3. Did this class memorize? Did I ask you guys to memorize your Pythagorean triples?
No.
No? Okay. That was, yeah, just pre-AP. So that is one of the triples. It's really easy, but since we didn't memorize them, we'll do the math. Not 6. So 3 squared is 9, plus 4 squared is 16. What's 9 plus 16? 25. What's the square root of 25? 5. So 3, 4, 5 is one of the triples that shows up a lot if you want to memorize just that one. So they do equal each other. And so then my statement I could write, instead of writing the perpendicular from the slope, I could just say JH equals IG with 5. Okay, so when you have that, come up here and star either method 1 or method 2. Which one do you think you would be more likely to use? My default's method 2. Doesn't mean you have to use it, but I'm letting you know that's what I like because then I can just work with the slope.
Wait, so that one is method 1.
This is method 1. This is method 2.
Yeah, Miss. What about the
Alright, so we're going to, this is the review of can you graph your points, find slope and distance for this one, and then we'll go over how to do those proofs. So we're going to take like, what do you do, 3 minutes or 5 minutes?
5.
Okay, 5 minutes to, in your groups, make sure you're staying focused. Everyone in your group should have it graphed and calculate out your slope and distance of the 4 lines. So our 4 lines would be AB, BC, CD, and DA. And we'll need slope and distance. Okay, so rhombus, just like rectangle, we have to have 2 statements. Okay, so statement 1, parallelogram first, okay? So I'm always going to default to my parallel line. So AB, anyone, AB is parallel to which side? CD. All right, and BC is parallel to DA. Okay, I only heard like 2 volunteers there. The rest of the room, am I going too fast? Do you understand why I'm labeling these parallel? Yes, no, you can give me a thumbs down. You want me to explain again? Yes. So I'm just taking the slopes I already found and labeling which sides that the slopes match. And I do have to put my numbers there to prove it. Okay, so that's my statement 1. So the statement 2 can be in any of these. Okay, so these are choose your favorite method. Diagonals are perpendicular. When we're talking about perpendicular, do we talk about slope or distance? So distance or slope. Perpendicular tells me direction or how long they are. Yeah, that's slope. Do you already have the slope of the diagonals? No, so I just have to count it. So AC would be up the 3 that I've already counted, and then over 4 plus the 5 that I've already counted. So it would be 3 over 9. What does that simplify to? 1 over 3. Okay. BD, if I count from B to D, what is my rise here? On your paper, am I going up or down from B to D? Down how many? Yeah, so just down 3 and over 1. Are those my opposite reciprocal slopes? Isn't that 1/3 and -3? Yes? No? Are those my opposite reciprocal slopes? 1/3 and -3. Yeah. So if I'm doing this method, I would just say AC is perpendicular to BD. 1/3 and -3. And I know this is a little bit short space. All right, next, adjacent sides are equal. So method 2, to me, doesn't make a whole lot of sense just to pick two sides are equal, but you can do that. You can say like AB equals BC. They're both 5. To me, the clearest one to always use for rhombus is because we remember rhombus means all 4 sides are the same. So this is always my default to just say, hey, AB equals BC equals CD equals DA. And all of those is 5. So just like the other ones, pick which of those are you most likely to choose. Do you like the all 4 sides equal like I do? Do you really like a different one? Put a star beside it so that you know what you'll use when we get to the homework and the assignment. And once you have that flip over, we just have one last shape. We're doing squares, and then we're done for today with the notes. Yeah, pretty much. We do the most shapes today. Okay, so the thing about squares is we have to have 3 statements because square is overlap of a parallelogram, a rectangle, and a rhombus. Okay? I put here my favorite. So my favorite is opposite sides are parallel, angles are right angles, and all sides are equal. They already did all the work for us here. We're just going to label it out. So my statement for square, I'm always going to start any of these shapes by labeling what's parallel or what's not parallel. So AB is parallel to, I got desk 25 this time. Chelsea, AB is parallel to which side? So looking at these. CD. And they're both a negative 4/3. All right, desk 2. BC is parallel to which side? DA. With the 3/4. Okay, so I just got, that's my statement 1. Okay, statement 2 now. I'm going to say we have right angles. Which symbol do I use to show right angles? A little perpendicular, and I'm going to list out all 4 sides. So AB is perpendicular to BC, is perpendicular to CD, is perpendicular to DA. Okay, and that's the slopes of negative 4/3 and 3/4. Yes.
So A, B, and C, you listed them as negative 4 and 3, but on the
Oh, did I list those up? Oh, I'm sorry. Okay. I messed up my proof. Thank you for pointing that out. 3/4 and negative 4/3. All right, statement 3. What's the third statement I need to make to finish this proof? No. So what's the third thing I need to write up here from the notes up here? All sides are equal. So we just did the all sides are perpendicular. So make sure you know these parallel and perpendicular based off the slope. Now we're going to do our distance statement. So just AB equals BC equals CD equals DA. Because they're all distance of 5. Okay, so that's what proves a square. Square has to have those 3 statements. Ooh, I'm seeing some sleepy faces. Do we need to turn the lights back on?
No.
Okay, let me see. You looking wide awake? Okay, this last one does, and you guys, this last one is what your assignment and your test at the end of the unit will be, is it doesn't tell you what shape it is. So you have to prove it out. Sometimes it's graphed for you, sometimes it just gives you this chart. Without looking at the graph, I'm going to first start by saying which sides are parallel. So desk 27 is empty. So I get to call in a volunteer.
Jordan.
Okay. So desk 7 and I do next, which is Gabriel. Gabriel, do I have any parallel sides here?
Yes.
So what's parallel to... Okay, wait, I called in Gabriel. Gabriel, what's parallel to CO? No, so parallel deals with slope. So it's true, it's the other one is 5. What's that line called?
Oh, never mind, I see it.
Alright guys, hold your side comments. We're almost done with notes. Alright, desk 22. Jordan, what's my other set of parallel lines? Hey class, we're still doing one talker. Right now Jordan is my one talker. Jordan, what's the other set of parallel lines here from this chart? Okay, desk 16. Who's 16? Are you 16, TJ? What do I look for next? After I've done parallel, what else would I look at here? So distance. So I have some distances that match. And then what else? Aside from parallel, there's one other thing that comes from slope. Perpendicular. Do I have perpendicular between 0 and undefined?
No. Yes.
Yes, 0 and undefined are perpendicular, and this one has a graph so we can see it. And so my next statement would just be CO's perpendicular to OA.
Is the PC supposed to have a line on top of it?
Yes. Okay, and that's with 0 and undefined. And then what shape is this? It's a rectangle. Okay, so I started by writing out what's parallel and perpendicular first. Here it's easy because it's graph for us and it's easy to see, but you won't always have the graph. So once you've copied this, flip over to page 20. Page 20 is coming next. No, it's classwork. And so, first of all, so you guys, what you're doing here is there's one shape that you need to graph, find slope and distance, and then find the proof. And then there's 3 more shapes where I'd already graphed it and found slope and distance, so you just have to write your proof statement and identify what it is. And then 22, part of your test is going to look like this. We're going to cross off, because we're a little short on time, we're going to cross off numbers 2 and 3 for today, okay? Yeah, just do a single line because we'll probably come back to them next class. So 2 and 3 of page 22. So page 22, you just have to do numbers 1 and 4 for today.